welcome back. Today we'll be going over the cosine graph. As the previous lesson, we're going to start with the basic cosine graph. And again, what better way to graph something than picking points? So I'm going to strategically pick some quadrant points. I'm going to start with 0, and we should all know cosine 0 is 1. And the next quadrant point I will pick will be 90 degrees, which is pi over 2. Cosine of pi over 2 is 1. The next one will be pi, which is 180 degrees. Cosine pi is -1. And go all the way to 270 degrees, which is 3 pi over 2. Cosine at 3 pi over 2 is 0. And making one revolution back to 360 degrees, which is equivalent to 2 pi. Cosine at 2 pi is back to 1. And again, I can pick more points. I can pick pi over 4. I can pick 3 pi over 4. The more points I pick, the more precise my graph will look. But I just want to give you a rough idea of what a basic cosine graph looks like. So I'm just going to use these 5 points. From now on, I'm going to call these 5 points critical points. Okay, I'm going to start my labeling. I'm going to go by pi over 2 as my x increment. So this will be pi. Next one will be 3 pi over 2. The next one will be 4 pi over 2, which brings us to 2 pi. I can also go to the negative portion, so this will be -2 pi. My y, I'm just going to go by 1. Okay, so I think I'm ready to graph this cosine graph. Cosine 0 is 1. Cosine at pi over 2 is 0. Cosine at pi is -1. And 3 pi over 2 is back to 0. And cosine at 2 pi is 1. So you can see I started here. I went to the middle, down, and middle, up. So we call that one full period, one cycle. It took 5 points. It took 2 pi to complete a cycle. And we call this the period. And I can mimic and go with the flow what I'm doing here to go to the negative portion. So this one was up at the amplitude, so the next point should go back to the x-axis. The next critical point will go down to -1 and middle and up. And cosine graph is just like sine graph. It goes on and on and on and on infinitely. Okay, but I just created 2 periods worth of graph. So that's what a cosine graph looks like. How is it different from sine? If you recall sine, I'm going to do a quick review right here. Sine graph starts from the origin without any transformation. In the next tick mark, we go up the amplitude. The next tick mark, we come back. And the next amplitude, we go down the amplitude, which is -1. And then the next tick mark, we come back. Okay, so sine graph starts from the origin and it goes up and middle, down and middle. Cosine graph, on the other hand, you start from the amplitude, you go middle, down, middle, up. So that's something that we all need to memorize. Now you have a idea what a cosine graph looks like. Now let's take it to the next level. Okay, let's do a quick review again, combining all the transformations. Cosine is just like sine. A standard equation will look something like this. A sometimes is positive, sometimes it's negative. But if you put an absolute value of A, that gives you the amplitude. Amplitude is how high, how low this sinusoidal graph goes from the x-axis. B is the coefficient in front of the x. Be aware, sometimes B is factored out, sometimes B is right next to the x. B is there to help us to find the period. How long does it take to finish a complete cycle? So to find period, we take 2 pi and divide it by B. H is the number that is inside the quantity with the x. The H provides us information about the phase shift, and this constant outside by itself will provide us information about vertical shift. Okay. All right, so let's do one complex equation graphing cosine that deals with all the shift. Okay, so I'm just gonna make it up. Let's do 3 cosine 2x minus pi plus 2. All right, what makes this question a little tricky is I did not factor out the 2. So on the quiz or test, what you might want to do is factor out the 2, so we put it in more of a standard form. Okay, I'm going to factor out the 2. If I take out the 2 from 2x, what's left is x. Subtraction, I'm just going to carry it down. Out of the pi, if I factor out the 2, what should go in there? Pi over 2. If you ever have trouble deciding that, you can always distribute it back to solidify what you did is right. So if I were to distribute 2 times x is 2x, 2 times pi over 2 is pi, okay, so I did it right. Now, the reason you should always factor out the b is because that's going to help you to decide what the phase shift is. So before I even graph anything, I'm going to start deciding things I know. Okay, what is the amplitude? The amplitude is 3 because a is 3. What is the period? The period is decided by doing 2 pi over b. b in this case is 2, so the period is pi. Do I have any phase shift? Yes, I have a phase shift to the right. And again, okay, if it's subtracting, it's actually shifting to the right. How much? Pi over 2. And I also have a vertical shift. And I'm shifting up 2. So these are all my transformation. Now, earlier in the previous video, I said something really important is deciding delta x. Because you're about to graph, you need to know how to label your x tick marks. So to decide delta x, and that's very crucial again on graphing, you always take your period, whatever you find the period to be, and you evenly divide it by 4. So in this case, the period is pi divided by 4, which is pi over 4. So that's how I'm going to label my x-axis. And that also tells me every pi over 4, I'm going to have a critical point. Okay, so I'm going to graph right here. Okay, again, okay, because I've decided the delta x is pi over 4, so I'm going to go by pi over 4. The next one will be 2 pi over 4, which is pi over 2. The next one, 3 pi over 4. The next one is 4 pi over 4, so which is pi. And another 1, 2, 3, 4 tick mark will bring me to 2 pi. And I can label some negative, so that's negative pi. And I think that's enough. For the y's, I'm just going to go by 1s. Okay. All right, I think we're ready to graph. So, like the previous video, we always do the shift first. Since we have a phase shift to the right, pi over 2, I'm going to take the y-axis and I'm going to shift it to the right, pi over 2. So this purple axis, I'm going to label this as y prime. That's my new y-axis. Vertical shift up 2, that's going to affect the x-axis. So I'm going to take the x-axis and shift it up 2. So this purple line again is my new x-axis. I'm going to call this x prime. Remember, whatever we graph from this point on, we're going to graph it from the new origin. Okay, so by shifting the axes, I have already dealt with the phase shift and the vertical shift. Now by labeling the delta x, deciding the period, I have already dealt with the 2. So now all I'm looking at is, okay, I'm graphing the cosine graph and the amplitude is a 3. There's no negative. So I'm thinking in my head, okay, so this is just a typical cosine graph. And again, a typical cosine graph, you start from the amplitude. So from the new origin, because it's a cosine graph, I'm going to go up the amplitude. How many? 3, because the amplitude is 3. So 1, 2, and 3. And my next tick mark, again, that's why deciding delta x is very important, because that brings you to the next tick mark. Cosine graph, you go back down to the x-axis. The next tick mark, the cosine graph will go down the amplitude. So 1, 2, 3 units down from the x-axis. The next amplitude come back to the x-axis, and the next amplitude you come back up the amplitude. So these 5 points will give me 1 period worth of a cosine graph. And I can continue on, but I'll go to the left side. So the next tick mark, if you go with the flow, you are up there, you should come back to the middle. The next critical point, I will go down 1, 2, 3, the amplitude, and the next tick mark, I'll come back to the x-axis, and the next tick mark, I'll go up, and you can continue the pattern, do as much graph as you want. but I think this is good enough. Okay, so here is my cosine graph with all the transformations included. Domain and range, real quick. Domain, again, I can pick as many points as I want. So the domain is all real numbers in the range. Range is the y value. So how high does this, what's the lowest y value? What is the highest y value that this graph has reached? When you decide the range, you have to remember to refer back to the original y-axis. So looking at this black original y-axis, it seems like this graph went as low as -1 and it reached as high as 1, 2, 3, 4, 5. So the range is from -1 to 5 inclusive.